Good afternoon, everyone. I'm Rahul Dhinakaran. I'm here to talk on the latest trends in design and manufacturing globally for India, to take you through the different eras in design and manufacturing from pre-liberalization era to the current era. Just a few points about me. I'm a mechanical engineer. I have over 17 years experience in design and fabrication of special purpose machines and consumer products. I have few patents which I have designed and developed for solving some social issues. I have worked in companies in China, Middle East, Australia, all over the world, including those in India. I am currently the head of machine design and manufacturing at Big Basket, Bangalore. Since 2016, I've been involved in design and manufacturing of some India-specific vending machines. I'm also the founder of Rahul's Tinker Shop, where I have all these patents. I have a hobby shop, which I offer real-time design solutions to some social issues in the domestic and industrial level. The points which I'm going to discuss and share with you over the course of this presentation would be post-liberalization. I have identified 3 or 4 phases and 3 or 4 models where I will tell you how the process went from design to manufacture. And I'll also be sharing some case studies from my own work over the past 17, 18 years, which I'm sure will help in understanding the various design to manufacturing path flows. The path followed during the post-liberalization era, from design to manufacture, the process followed would be, they would be designed 3D modeling, a variety of European tools or American tools, CATIA, SolidWorks, Creo. These are the common suspects, actually. We'll be talking about a lot of these softwares over the course of this presentation. But the modeling was done in Europe, mainly using this. Then manufacturing drawings were done in Europe by draftsmen over there. Mind you, this was post-liberalization. We were just about 40 years after independence. We were not yet bitten by that industrial age bug. So the manufacturing drawings, we were not that good in manufacturing drawings and making tooling and all that. Even though we had a few success stories, they were far and few compared to Europe and other countries. Teams of engineers from Europe and Southeast Asia would visit our country and they would study the market. They would go back and design the tools and dies. They would be manufactured outside India and they would be shipped to India. The Ford Escort dies, the Opel Astra dies, they were all made in Germany. They were not made in India as such. So the Indian manufacturer, we would learn to modify these imported tools. We would learn from these tools how to make these tools and presses and the quality which these European giants they expect. The Indian giants, designers, we would actually train ourselves to be accustomed to reading these European drawings and relate to that level of quality. From 2000 onwards, the Indian design to manufacturing process would change. There would be 2 or 3 models. Our first model would be the 3D modeling would be done, and there were lots of 3D modeling courses available. Then 3D modeling started. Engineers from various institutes started learning 3D modeling. So we would do the 3D modeling. The manufacturing drawings again would be done in India. We started doing a lot of manufacturing drawings using the same tools to European standards. We would save the drawings in uneditable format in PDF or anything. We would give it to an Indian manufacturer. The manufacturer would read drawing, the toolings would be made, and the manufacturing would start. This was the first model, where an Indian design to Indian manufacturing process to an Indian manufacturer. So this is the first model. The case studies, there were lots of those automation companies started their operations in the early 2000s. So one of my early customers was based in Delhi. They were making conveyors for a lot of automotive manufacturing companies. So the first product which I made for this company was a belt conveyor with a pop-up sorter. The parts of this conveyor were a lot of imported components, like bearings from SKF, a pop-up sorter from an European company and all that. The tools which I used were SolidWorks. There was no simulation involved as such because there was no stress analysis required. The manufacturing drawings I again did using SolidWorks, where the tools, with these tools, there was no need for a separate draftsman from the 3D modeling to a draftsman. There was no need for a draftsman. The designer himself could draft if he was familiar with the drafting techniques, and he could send it to a manufacturer. Here, the manufacturer was based in Delhi. We prototyped in 3 months. The issues faced, we had some issues when we couldn't import some parts, the pop-up sorter. the bearings and a couple of parts. Other than that, there were no issues. We machined everything in-house. The requirements were all perfect. It came out very well, this product. Then the next model would be an Indian design to an overseas manufacturer, where the design would be done in India. 3D modeling is done in India using the same suspects, SolidWorks and everything. The manufacturing would be done in the manufacturing drawing would be done in India. We would send the drawings overseas in editable format. In the previous model, we would send the drawings in uneditable format. Here, we would send it in DWG format. The overseas manufacturer, they had their own designers working in-house. They would make some changes if required based on their machining capabilities. And then they'll send it back. We would freeze the design, and manufacturing would start. So this, the case study which I'm going to present for this model 2 of this phase is an NVH reduction in mobility in diesel generator, where we bought an generator from an Indian manufacturer. It was a very crude generator. We bought it. We did some changes in that generator. You'll see what the changes are. We reduced the NVH level. The NVH, the noise, vibration, harshness in this particular diesel generator is very high. You cannot run the generator without deafening anybody in the nearby surroundings. So we did that. And the main reason which this customer wanted this mobility increased in this generator was, he felt that the current generator, they were difficult to move in within the premises of an office or a community as such. So he wanted a solution where he could just mount this generator on a, let's say, a pallet truck, a load carrying pallet truck, and he could use it, he could just move it anywhere. Again, the tools used for designing is SolidWorks. Here, static FEA was required. We used Cosmos for that. The time to prototype was 3 months. The challenges which I faced mainly were the cost to target challenge, because this was for a low income group of customers. The changes which I had to make shouldn't cost that much. So we had to keep that in mind while introducing parts, while even though we reduced NVIDIA noise, vibration, and harshness, there still had to be a cost target to be met. We couldn't use some technologies which were available at that time, which would shoot up the price. Mainly when we move from design in India to manufacturing in China, the challenges which I mainly face, which I've been facing for the past nearly 10, 15 years, was the language, the engineering terminologies, particularly. As I mentioned before, the design was done in SolidWorks. The FEA simulation for a few components was done in Cosmos. The prototypes was developed in India. We made the prototype drawings ourselves using the above softwares. The prototype we developed and we showcased it to our customers before shipping it and shipping the prototype and the design. The overseas manufacturer and myself, the Indian designer, we collaborate before starting manufacturing. We help him understand the design. We help him understand the prototype, how it works and all that, and over Zoom calls and other online sharing tools. And then we help them start the manufacturing. The manufacturing expect to start in another year or so. This is the initial crude Agra genset, which we bought from Agra, which we sourced from Agra. You can see that it's a normal diesel twin cylinder generator with an alternator. It's mounted on a platform. This was the refined design, which I made using SolidWorks. This is a SolidWorks design. I'll show you the actual prototype in the next few slides. This, you can see that in the center, there is that yellow and blue part, and the bottom, there is that orange pallet truck. So these were the 3 components which we added to the yellow and blue part. They integrated the vibration and they ensured that the whole engine and the alternator, the vibrated together, and they were mounted using on the pallet truck using a rubber vibration isolation mounts, engine mounts. The orange component is the pallet truck, which would take a load of around 1 ton. This diesel generator weighed about 500, 600 kilograms. So it was easy to move around in a variety of surfaces. This is again another view of that diesel generator. The yellow, blue, and orange components were the components we developed over here. This is the basic static analysis on the center component, the housings, cast iron housings. This was the prototype drawings. Okay, when we make the prototype drawings over here in India, we have to give the whole drawing of the of the component. Here it's a sand casting, so I have to give the pattern drawing, and then based on the shrinkage and all, which is what we have done in that table if you see in the top left corner. This is the finished prototype. This was completely made in India. The center orange components were what I showed you as yellow and blue components. The bottom yellow is the pallet truck. You can see there is a you can see at the bottom of that generator, you can see the rubber engine mounts which were used to isolate the vibrations. This was the first prototype built before shipping it out to the overseas manufacturer. So this is the next case study. This is for a company in Ireland. This again, the design to prototype, we did it over here in India before shipping it out to the manufacturer in Ireland. The drawings, the modeling, everything was done using SolidWorks. This is a wheelchair hub where normal, I'll just give you a brief on the product. A normal manual wheelchair has a single rim where the user has to push the rim to move forward and back. If there is an incline in his path, he again has to push it harder to move it above the incline, which is hard. The motorized wheelchair, electric wheelchair, they have the facility of having an electric motor in them where it can easily handle the inclines, but they are very expensive. This particular manufacturer wanted a setup where the wheel had a second rim, where the user could use the second rim to move forward and backward in case of an incline. So that rim had to be connected via a planetary gearbox. So that planetary gearbox, which it developed in India over here, we designed it, we manufactured it, fixed it in the wheelchair, and we shipped it to Ireland along with the designs. So the next model which I'm going to talk about is the same from post-liberalization phase 2, the collaborative design process. So this is the start of the era of collaborative design where an Indian designer is allowed to participate in an overseas design process. There would be usually the brainstorming session either would take place in Europe or will take place in India. But over here in the collaborative design process, the brainstorming session would be a collaborative process between the Indian designer and the overseas designer. The design would be shared. We would do the design in India. We would share it to share it to the overseas designer using formats like STEP and IGS and everything. And the overseas designer there would make the final changes based for his local manufacturer, which he would understand better than us. And then he would send back the edited designs to us. We would design it over here and we would send it to the overseas manufacturer. This was a way where the Indian designer has to design it to the requirements of an overseas market for an overseas manufacturer. Designing for an overseas manufacturer is the critical part of it. Designing for an Indian manufacturer by an Indian designer is much easy because of the local languages and everything. Designing it for an overseas designer or an overseas manufacturer is the critical part. This was a case study which I developed for a company in Bend, Oregon, the US of A. This was a drawer assembly, a normal drawer, a furniture. This was a furniture company. You have a lot of tables and drawers over there. They wanted a machine to assemble their drawers. So it was the same process, SolidWorks. I'm more familiar with SolidWorks. I've been using it for 18 years now, from the initial non-collaborative era to the current collaborative era. So it was the design. There was a senior designer based in Bend, Oregon. He guided me on the components to use. I cannot use local Indian components over here. Simple reason, they won't be available in the US. So I had to use what was available in their catalog, the fasteners, the locks, the even basic things like nails, the sizes and all that, washers and all that. So he gave me a list of that. I have to design it based on that catalog, and then I send it to him. He does the final changes on that product and gives it to the manufacturer. So this is the current era. This is the third model. This is the second or third model. This is the current era. I have not yet done any projects in this type of collaborative process, but this is the process which is going to be the future. And this is what is starting now. So here, what it is not like we design and we send it to an overseas designer, or the overseas designer designs it and sends it to us. There are tools like Onshape and Autodesk, Fusion 360, and all that, where design can be done simultaneously by an Indian designer and an overseas designer on the same product file. So this way, let's say a product has 5 or 6 sub-assemblies, complete product assembly has 5 or 6 sub-assemblies. There would be 2 or 3 designers working on it at the same time on various sub-assemblies. So the time to take into market is completely reduced, and the understanding of the product can be shared immediately. There is no time gap for a brainstorming session where an Indian designer doesn't understand an overseas market design, or an overseas designer doesn't understand it. There's nothing like that. It's just done simultaneously, where an Indian designer and overseas designer sit together, they start designing, and it's just done. All the parts are shared, all the part catalogs are shared. In the earlier model, you saw that where the American designer had to send me a part catalog, I had to choose products and all. No, here everything is inbuilt. The overseas designer shares its parts with me immediately, and I share my parts with the overseas designer immediately, and it's just done on the same file using. These are the tools which are having the market share now: Onshape and Autodesk Fusion 360. So this would be the future. That's it.